Hi, this is our next episode of Localization Horrors, the Pseudolocalization. What if you could test for localization failures before a single translator has been hired, before a single foreign language string exists, and before the product has even decided which markets it's targeting? What if you could break the international version of your app on purpose while still only exists in English? That's not a trick question, that's pseudolocalization. And once you know about it, you will wonder how you ever shipped without it. Today's episode is a short one, but don't let that fool you. What we are covering might be the single most elegant proactive testing technique in the localization toolkit. We are talking about pseudolocalization, the art of simulating translation before translation even exists. Here's the core idea. Pseudolocalization is a process where every string in the application gets automatically replaced with a modified version. Longer, filled with accented characters, wrapped in brackets. That looks vaguely like it came from another language, but still readable in English. So submit, for example, becomes submit, but with accented characters, with underscores, and wrapped in squared brackets. It's not a real language, it's a simulation. And in about 15 minutes of setup, it can expose problems that would otherwise take months of translation cycles and market launches to discover. The beauty of this technique is timing. Every bug found through pseudolocalization is a bug found before it costs real money, before it embarrasses the company in real market, before the real user encounters it. That's not just efficient testing. That's the entire philosophy of shift left in action, applied one of the most commonly neglected areas of quality. English is a compact language. It says a lot in relatively few characters. German, Finnish, and many other languages routinely need significantly more characters to express the same concept. French and Spanish typically run 20 to 30% longer than their English equivalents. Hungarian, and this one is close for me to home, can produce compound words that make a UI designer quietly weep. So, when a button is designed to fit the word settings and in German translation becomes Einstellungen, something has to give. Either the button grows, the text wraps, the font shrinks, or most commonly, the text gets clipped and the user sees something that doesn't quite make sense. Here's a list of tools that you can use in your project. Pause the video and save it for later. JavaScript or React have pseudolocalization. Angular has built-in localization library. Java has resource bundles and also internationalization pseudo library. For iOS or macOS, you have the Gen strings. Android has custom Gradle task. And basically any platform has a manual script written in Python or Node.js. So, step 1. Prepare your string files. Locate all string resource files in the application. These are the files in your internationalization framework uses to look up in the UI text. Something like .properties, .json, string.xml, strings, or something similar. Step 2. Generate pseudo-strings. Run your pseudolocalization tool against the copied string file. A well-configured pseudo-transform does 3 things simultaneously to every string. Replaces characters with accented equivalents. This surfaces encoding issues. Second is expands the string length by 30 to 40% using padding characters, such as underscores. This simulates the longer strings common in German, Finnish, and other languages. And the third is that it wraps each string in visible brackets. So untransformed strings are instantly identifiable during testing. Step 3. Configure the app to use pseudo-strings. Point the application at the pseudo-generated resource file instead of the real default language file. How you do is depends on your framework. Set the locale language parameter to your pseudo-locale, that is commonly an N, XA, or XX pseudo, something like that. In development environments, this is often a single environment variable or a build flag. If you have CI pipelines, then in CI pipelines, run the build with the pseudolocal enabled as a dedicated test step. Then confirm the app is loading pseudostrings by checking any clearly visible UI label before proceeding. Step 4, you are done. Execute the test to check the localization. Walk through every screen and interaction in the application systematically. Your eyes are looking for 4 specific failure types. 1. Any text that appears in plain, unmodified English is a hard-coded string. It was not processed by the pseudo tool because it was never in the resource file to begin with. 2. Expand pseudostrings will overflow any UI element that was sized only for English text. Look for truncated or copied text in buttons, labels, menu items, and so on. 3. Accented characters in pseudostrings will break any component that is not handling Unicode correctly. 4 is the missing or broken UI elements. Some components have minimum or maximum width assumptions that pseudostrings violate. And that's it. You are done. So, the hard-coded text is the cockroach of localization. Every application has hard-coded text, strings that were written directly in the code instead of stored in an external resource file. A developer was moving fast, the deadline was pressing, and handling it just as a hard-coding string was even just easier at the moment. These strings never make into the translation file because they are not in the translation file. They are buried in the codebase. When the translator receives the resource bundle, those strings simply aren't there. And when the localized version ships, those hard-coded strings appear in the original language, floating in the middle of an otherwise fully translated interface, like a tourist who got on the wrong bus. Pseudolocalization finds them immediately. When the entire interface is running in pseudo mode and the string appears in plain, unmodified English, that string is hard-coded. So, what is the QA lesson here? Here's the uncomfortable truth about reactive localization testing. By the time you are testing a real translated build, you are already late. The translation is paid for, the time is committed, the market launch has been announced. Finding a systematic layout problem at that stage doesn't just mean fixing a bug. It means potentially redoing translation work, redesigning components, and having a difficult conversation about why this wasn't caught early. Pseudolocalization is the answer. It's the technique that lets you catch it earlier, structurally, systematically, and without needing to wait for any external dependency. You don't always get credit for the disaster. That didn't happen. But you know, and the product is better because of you. That's the job. And it's worth doing brilliantly. Test thoughtfully, friends. See you next time.